All right, so let's look at the review questions. So if you will, answer questions 1 and 2. That is hilarious. They do go from problem 2 to 4.
Counting problem in a math class? Yeah.
You're a funny one.
They should take math.
Okay, so in triangle ABC, or triangle ABC is congruent to triangle RST. So everything that you know about congruent figures comes into play. Name the side that corresponds to side BC. ST. And make sure that you use proper notation. In the diagram, and that's the diagram here, in the diagram, R is the blank of line AB. What do you notice about the markings? So what does this tell you? Perpendicular, and what does this tell you? Bisects it. So what is R? Perpendicular bisector. Put that away. It was under your desk?
Yeah.
Uh-huh. All right, so then we're going to look at the word reflection today. So the reflection, you like to call a reflection a flip, but that just describes what it is. It's not the proper terminology for reflection, so you're technically not allowed to call a reflection a flip, just to let you know. You must call a reflection a reflection. But a reflection is a transformation which flips a figure over a line of reflection, so it goes over a line of reflection, so here's the flipping, resulting in a mirror image, meaning that the size and shape of the figure has not changed. The orientation of the figure reverses. And what's really important is that every single point, so as you can see, this figure is a reflection of this figure or vice versa. This line right here, this vertical line Y, is the line of reflection. And every point is equal distance from that line of reflection. So in other words, point B is 1 unit away. Its corresponding point would be point M, and it's 1 unit away. A is 3 units away, and A's corresponding point is L, which is 3 units away, and so forth. So every corresponding point is the same distance from that line of reflection. In fact, I could take and fold, if I had this on paper, I could fold the paper right here at the line of reflection, and that this figure would lie exactly on top of that figure. So that's really how you could tell if something's a reflection. So let's look at 3. Is number 3 a reflection, yes or no? Could you fold your paper here, and you have your paper, you could fold it. Could you fold it here, and would this fold directly over on top of this one? No, because this would be laying here, right? It would end up going in this direction, wouldn't it? And so the answer here is no. What about the second picture, the thunderbolts, lightning bolts? Yes, this is. And for some of you, reflections are going to be hard. They're going to be really hard because it's a visual thing and it's a spatial thing. And you'll have to watch me because I don't see things the way normal people do. I have a lot of eye issues, in case you haven't figured that one out. And so oftentimes I have to cheat and reflect that way. So if you ask me to reflect the letter S, I can't do it. I'd have to cheat. Bless you! That's hilarious. So if you asked me to reflect the letter S, I personally would have a whole lot of issues with that. But I could reflect it if I folded paper and had it drawn, folded paper, and then drew it on the back, and then opened it and drew it again on the front. No, not quite. But here's how you can reflect. Here's how you can reflect anything. So look at number 4. Here's your line of reflection right here. And if you can find vertices on something. So I have troubles with curves. personally, because it's really hard for me to find a vertex. If I have a vertex, then I can reflect it, because I want to make sure that A, its reflection point is the same distance away, and same with B. So let's go ahead and reflect. If I drew a line from here to here, I don't know, you might say that that's 1 unit away, let's say. Then you want to draw a line the same distance away on, oops, it's going to be a little hard, on the other side. And so then I'm going to plot my point for B right here. And I'm going to call that B prime. And then if C is this far away, then it's going to be the same distance away on the other side of the line. And so I'm going to plot this point here and call that C prime. And then same thing with A. A follows along the same line as B, so A is from here to here, so I'm going to plot it from here to here, let's say. So maybe A goes out to here. And I'm going to call that A prime. And then I can connect. Of course, you would connect with a straight edge. I cannot connect with a straight edge on here, but look at how straight that is. That's awesome. Okay, so I'm a little off to the left, but you get the idea. And there's your reflection. So obviously you're going to be using graph paper. So when you do your homework tonight, if you don't do it on graph paper, I'm not giving you credit. You can always go to the internet and print out graph paper. Graph paper was one of your supplies you were supposed to have for this class. So make sure that you have it, because it's really important for reflections. All right, so let's look at. So key concept, and you're going to see a change in notation. And so let's make sure that you understand that change in notation. So as you read this, we have a reflection across any particular line, and reflections always will occur across a line. Called the line of reflection is a transformation with these two properties. And it looks like they've given you 3 properties though, doesn't it? If point A is on line M, so if it's physically on the line, and so look at this picture right here, isn't point A on the line of reflection? So if point A is on the line M, then the image of A itself, the image of A is itself. In other words, its reflected point is the same position. In other words, A is on the line, so A prime is also on the line. They are the one and the same point, and that's all that that's trying to tell you. Versus you've got B here, which is off that line of reflection. B is this distance right here from the line of reflection, and so B prime will be the same distance. So the distance from B to B prime is bisected by that line of reflection. And so the line of reflection becomes a perpendicular bisector to the line that would contain or connect points B and B prime. And that's all that they're trying to say here. And then this is your notation. It looks a little weird, doesn't it? If you write the reflection across M that takes point P to point P prime, this is your notation right here. And here's how it reads. R means reflection. M is telling you what you're reflecting over, and it's a line. It's in lowercase cursive letters. And then P is the item being reflected. So we are reflecting the point P over the line M, and we get the point P prime. So you might want to write yourself a note that this means reflection, and that's what the R is for, of point P over line M. And then I did decide that we're going to talk about 5 through 8. They look a little gobbledygookish, but bear with me. So reflections preserve distance and angle measurements. So if they preserve distance and angle measurements, is it a rigid motion or not? Yes or no, rigid motion or not? It is a rigid motion. So I want you to put in here that reflections are rigid motions. They didn't mention that, but a translation is a rigid motion, and so is a reflection. So here it says if, and let's look at the notation, if the reflection of point A over the line M is equal to A prime, and the reflection of point B over line M is B prime, so we've got A prime and B prime, then segment, or the distance is what that's saying, the distance from A to B would be exactly equal to what? Distance from A to B is exactly equal to what? A prime to B prime, wouldn't it? All heads are off the desk. And that's just one of the key concepts that they have above in that box above. And then they go on to say, because that's preserving distance, now we're preserving angles. If the reflection of angle ABC over the line of M is equal to angle A prime, B prime, C prime. So here's angle A, B, C. So from A to B to C, they're talking about that angle there. They're saying that that angle there is congruent, which makes sense. And so then the measure of angle what? Take this and put it here. So the measure of angle ABC is equal to the measure of angle A prime, B prime, C prime. If the distance from A to C is 3 units, so if this distance from A to C here is 3 units, then A prime, C prime, that distance is equal to what? 3 units also. And then this one, if the measure of angle ABC is 55 degrees, then the measure of angle A prime, B prime, C prime is what? 55 degrees. So that's something that might come up in your problems assigned to you today. Let's look at problem 1. Reflecting a point across a line. This is difficult if you don't know how to plot vertical and horizontal lines. So let's just put here as an aside, x equals a number, and we talked about this yesterday with one of your homework questions. X equals a number goes through what axis? It goes through the x-axis. So if it's x equals, it goes through the x-axis. So this is a line that goes through the x-axis at whatever that number is. And so then y equals a number goes through what axis? Yep, it goes through the y-axis. So it goes through the y-axis at that number. So on question 9, look at the notation. The notation is saying we have a reflection of the point P across the line x equals 1. So we're going to have to plot that line x equals 1. And we get P prime. So they've given you the, did they give us the coordinates of P?
Yeah.
Oh, above, right here. I thought they had. I was just missing it. So here's your coordinates of P. And then this is the line at which we're reflecting over. So let's go ahead and plot in that line of reflection. So it goes through what axis? X-axis at what point? So is that a vertical or a horizontal line? Okay, so you might want to add to our notes up here that this is a vertical line. And so this one's a horizontal line. So here's our vertical line going through the x-axis at 1. And it is a dashed line because technically it is not part of the graph. And so this is x equals 1. And we're going to plot the point P at positive 3, positive 4, which is right here, and we're going to label that point P. So then answer the questions below. Describe point P in relation to the line of reflection. So point P is what in relation to the line of reflection? 2 units, what direction? To the right. So we are 2 units to the right. Describe the image for P prime. So what's P prime going to be? 2 units to the left, always in the opposite direction. And so if we go 2 units to the left, won't point P prime be here? And what is the ordered pair for P prime? That would be -1, +4. So that's not so bad. The hard part on that one was graphing that line x equals 1. All right, so look at, and we're going to ignore the top part of page 3 because we just answered all those questions, right? So we just answered all those. See page 2. And then problem 2, now we're graphing a reflection image. Fortunately, they graphed triangle ABC for you, and the notation says that we are to reflect over the x-axis, and we're going to get triangle A prime, B prime, C prime. So they're showing the x-axis as a dashed line of reflection. So we're going to go ahead and, if you have colors or even a highlighter, I would highlight this line right here because that's our line of reflection. And what is the equation of that line, by the way? What axis does the x-axis go through? What axis does it go through? The y-axis. So this is y equals, and at what point on the y-axis? 0. So that's the equation of that line. All right, so then when we plot our points, notice that point A is how far away from this line of reflection? How many units? How many units? How many units? 4, right? So then we went 4 units below the line to get to point A prime. So we're going to do the same thing. B is how many units away from the line of reflection? 1. So, and for some of you, if you have visual issues, I would be drawing these distances. And so then we're going to go 1 unit on the other side, and we're going to plot point B prime. And then C is how many units away? 2. And so we're going to go 2 units on the other side and plot C prime. And then we're going to connect with a straight edge, which your thing hanging around your neck, that ID is a perfect straight edge for this. We're going to connect those points, and then that becomes your reflected image. And consequently, bless you, we drew a weird 3-dimensional figure. It's not the same as when you translate it. It won't come out to be looking like a proper 3D figure. All right, then we skip apparently problem 3 and go to problem 4. Terrific. And it says here in this diagram at the right, it says the reflection of point G is over line T. So here's line T. The reflection of point G over that line is equal to G. Why is G equal to G and not G prime? Bless you. Because it is, bless you. Goodness, a lot of sneezing today. Because G is on the line of reflection. So if a point is on the line of reflection, it's not going to equal G prime, it's just going to equal G. Although if you called it G prime, I'd be totally okay with it, to be honest. And then H is reflected across T, and it becomes J. And so what they're telling you is that H and J correspond to each other, and they are equal distances from that line of reflection. So if they are equal distances, I would be putting a tick mark here and a tick mark there. Here a tick mark, there a tick mark, everywhere a tick, tick, tick mark. Let's have a little fun. And then the reflection of D over T is also D. Why? Again, because it's on that line of reflection. So the question says, can you use properties of reflection to prove that triangle GHJ is equilateral? Explain how you know. Well, question 15 says, how do you know that a triangle is an equilateral triangle? First of all, how do you know that you have an equilateral triangle? All three sides are equal. So use the properties of reflections to compare the side lengths. GH is exactly equal to what? GJ. So GH is exactly equal, get my, so then I'm going to put double tick marks on those sides. And HD, we already know, is exactly equal to DJ. And then what do you know about GD and GD? GD is equal to GD because of the reflexive property. And so we do have two congruent triangles, don't we? Within there, but is there any way to tell that the entire triangle is congruent? That, or in other words, that all three sides on here are congruent? Not by properties of reflection. By properties of reflection, I can only prove that that is congruent to that that distance is congruent to that distance. And so the most I could prove is that I had two congruent triangles, not that I have an overall equilateral triangle. So question 17 on page 4 says, can you determine if HJ is congruent to GH is congruent to GJ using the properties of reflection? No. The properties of reflection cannot be used to prove that triangle GHJ is equilateral, but they can be used to prove congruent figures. Or they can help to get there. It depends on what figure it is and what you have. All right, so let's do the lesson check. A classmate sketched the reflection of point A over line R as A prime shown in the figure. So here's point A, here's the line of reflection, and here's A prime. Explain your classmate's error and copy point A and line R and show the correct location of A prime. Well, they've got it down here, right down here, so you don't have to copy it, you can just put it down there. All right, so go ahead and answer. I will give you 1 minute to consider it. All right, so when you're done answering the questions, or you might even have gotten stuck, I want you to talk to people around you and see what they think about it. What? Well, don't talk to me, talk to people around you. Who's stuck? Who doesn't know what to say? So it's a hard one, right? All right, so let's look at 19. Use the properties of reflection to describe how the line of reflection is related to A, the line segment A to A prime. Okay, so he's drawn, or she, we don't know who the classmate is, he's drawn a line from A to line R. What was that?
Well, he made a mistake, so we know it's God.
Well, that's not necessarily true.
Well, according to you, the eyes already.
We'll talk about that when I'm done. From A to from A to the line of reflection and from the line of reflection to A prime, they have drawn congruent segments. But what's wrong with this line?
It's not.
It's not what?
It's not perpendicular.
It's not perpendicular,
Yeah.
and that's the problem. The distance from any point to a line, if you go all the way back to August, the distance from any point to a line must be a perpendicular distance, right? And so that's his biggest problem. So line R should be the perpendicular bisector of line segment AA prime, and it's not. And so down here, we want to draw a perpendicular, okay, I'm just a little off on the other side. So we want to draw something that is perpendicular to the line of reflection. And so then, and also equal distances. So it's not enough to be an equal distance. It also has to be a perpendicular bisector. So examine the classmate's drawing. What was the classmate's error? So in the drawing, line R is not perpendicular to AA prime, to line AA prime. Any issues, problems, concerns? Good.